If we see two triangles that are meeting at a point, which we've already encountered, but what is new this time is that we have the symbol for parallel showing up in our given information. And so, again, our given information is not telling us that something is congruent to something else, but this information is supposed to lead us there. So, let's just remind ourselves what's important about parallel lines. If you recall, when we have two parallel lines and a transversal that cuts through them, we have four angles in the top and four angles in the bottom. And if you remember, what was important about this is that the top four angles were the same as the bottom four angles. They all matched each other. And so, how is that going to help us here? Well, if we think about what that means for these angle groups to be the same, we had certain kind of angles that were congruent. We had corresponding; those were congruent. We had vertical angles that were congruent. It's like 5 and 8 here, and 4 and 5 here. And then we had these alternate angles that were congruent, such as 4 and 5. Those were alternate interior, and 1 and 8, the alternate exterior. But I want to draw attention to just two of these, 4 and 5. Because these angles are between lines, those are the angles we're going to encounter most often with our triangles because we talk about the angles inside of the triangles. And so when we see that we have parallel lines, what we are going to look for are these alternate interior angles. Once you know that you have parallel lines, it is now guaranteed that alternate interior angles will be congruent. So we're going to look for that here. And so let's first recognize which lines are parallel. That would be segment AB and segment ED. And so we have transversals connecting them, and we actually have two. And so this is your call on what you want to do. Because you know these lines are parallel, we could either talk about the alternate interior angles A and D, or we could talk about the angles B and E. In both cases, these angles are created by our parallel lines, and so it is a guarantee that they are congruent. So it doesn't matter which pair you pick, just pick one. In this case, let's say we pick angles A and D, and we'll mark those angles here as well. Okay, and so that reason is not given. That reason is because we knew we had parallel lines. And so this is one of the few reasons that we're going to write out a little bit longer here. It just says if you know you have two parallel lines, and so we'll write that a little shorter, if two lines parallel. So if you know that you have two parallel lines, then you should also know that alternate interior angles are congruent, which I'll say here, abbreviating some things, using some symbols for words such as angles and congruent. So we'll look for that. Anytime we see parallel, let's look for alternate interior angles. Okay, now technically we could do that again. In our next diagram, we could also talk about why B has to be congruent to E, those two angles, because again, they're alternate interiors. But let's try a different route here. Let's try using our second piece of given information, that C is the midpoint of segment BE. And so remember that word midpoint is important to us. It means that we have a point C that is directly in between two other points. It's the halfway between points B and E in this case. And so if C is the direct center between B and E, that would mean that the distance from B to C is the same distance as C to E. And so there we have a pair of sides that are congruent between these two triangles. And we won't put given because in our given info, it doesn't say that segment BC is congruent to segment CE. It's because we had this special word midpoint. And so that's where this reason that says definition of midpoint is coming into play. All right. And so we need a third piece of information like we always do. And remember, you can't just look at sides and say that they look the same. You need to have a reason, whether it's the word midpoint or the word bisector, or it's a side that's shared by both triangles. And we don't have a shared side here. So we can't talk about any more segments, but remember, we do have options to talk about angles, whether that is talking about the other two alternate interior angles because you know that the lines are parallel, or remember, there's always a guarantee, whether you have parallel lines or not. When you have two lines that cross each other, you are always going to have vertical angles. And remember, those vertical angles are going to be congruent no matter what. That is a very important guarantee that we should always keep with us. And I'm going to choose to go that route. Either way you did this, whether you used the vertical angles or you used alternate interior angles B and E, we're going to have the same theorem happen. Because I used the vertical angles, I'm going to put definition of vertical angles. But it does so happen that no matter which route you took, when you look at the setup, it's always going to be that you have two pairs of angles and you have a side marked that doesn't happen to connect those two pairs of angles. And so this is angle, angle, side rather than angle, side, angle.